In this video, you will learn how to create complex custom fusion tools that you can reuse in your projects, which will speed up your work. We will cover expressions, custom controls, linking properties, the creation of macros, and a bit of math. Let's get started. Create a new Fusion composition on the Edit page and switch to the Fusion page. Welcome to our blank Fusion composition. We'll start by designing the bar itself. Our goal is to create a tool that can be used each time we want to draw a bar. In Fusion, shapes are created using a primitive tool like polygon, ellipse, or rectangle. They are given color using the background tool. By the way, I used the Add tool dialog to add new nodes to my composition. The hotkey is Shift plus Spacebar. You'll see me using that throughout this tutorial. Feed the output of the rectangle tool into the mask input of the background tool. To view the shape I've created, I could equip either one of these nodes in the left-hand viewer, or as the media out node is already being displayed in the right-hand viewer, I can connect the output of background node to see the entire composition. Here's our first big opportunity to simplify the process of building these bars. Several of these bars will always need to be displayed in any one graph. Imagine if I needed to define the size and position separately for each bar. Let's create some custom controls to streamline the process. The graph isn't going to fill the screen, so let's create controls that allow us to define the left, right, top, and bottom margin. Custom controls can be created on any node in your composition. The dialog for doing that is accessed from the node's right-click menu. In this instance, I'm creating them on the rectangle node. This dialog allows you to edit existing controls and create new ones. It's not immediately obvious, but to create a new control, just start typing a name. It's important that this name doesn't conflict with the names of any existing controls. This field here allows you to set the control's ID. This field here allows you to name the control. This shouldn't have spaces. Names can have spaces. That's why these two fields look similar, but are ultimately different. Before we go any further, there's something important that you need to understand. Fusion typically uses relative coordinates to define position and size. That means instead of talking about pixel values, Fusion talks about how big something is compared to the entire frame. So for example, instead of something that is as wide as the frame, being 1920 pixels wide, it's defined as 1 wide. Understanding that will help you to understand why all these position controls I'm creating won't typically have numbers greater than 1. Back to the new control we are creating. It's going to hold a number value. I want a slider control. It's going to be a decimal number, so we need to make sure integer is unticked. This is always going to be a positive number. We're never going to have a negative margin. I'll set the default to 0.1. I'll set its range to start at 0 to 0.5. You're never going to want a margin that's more than half the width of the screen, right? So I'll set the allowable range to match 2. Finally, make sure that the property is animatable and it's not passive, just in case we ever think of a cool reason to animate the margin in the future. Hit OK. I'll go through that process again to create a right, top, and bottom margin property. Here's all the controls I just made. They are in their own tab called User. If you'd like the tools to appear in a different tab, that's something you can control in the Edit Controls dialog as well. Those margin properties define the part of the screen on which the graph will be drawn. But the height of each individual bar will depend on how many bars are displayed in a graph, and its position will depend on which bar in the chart it is. Let's create a control that defines the number of rows in the graph. I'm calling it rows. It will be another number field with a slider. I'll set a default value of 10, a range of 1 to 20, and an allowable range of 1 to 100. That means by default, the slider will only go to values up to 20. That makes the slider a little friendlier to use. But if you use the keyboard, you can enter values up to 100. Of course, it needs to be an integer value. We can't half a row. Next, a position slider. This will define which row on the graph this bar occupies. I'm calling it position. I'll give it the same properties I gave the rows control, except I'll set the default as row 1. I'm going to make this an integer control for now, but I might change it to work with non-integer values later. That will be helpful if we want to animate the position of a bar. If only integer values were allowed, the bar would jump from position to position, but the non-integer values will allow it to move smoothly. Finally, I'll create a padding slider. This will control the amount of space between bars. We don't want them touching each other. I'm going to define the padding between bars as a factor of the bar's height. That means the bar padding will adapt to suit the number of rows. Otherwise, if I was to define it as an absolute value that didn't change, then I could have issues when there isn't enough room for the padding I have defined. This control needs to be able to have non-integer values as I'm defining the margin as a decimal factor rather than a percentage. I'll set the allowable range from 0 to 0.5. That means if I set a padding value of 0.1, then the space between bars would be 10% of the height of the bars. Now that we're done creating all those controls, we can write some expressions to build the shape of each bar. First, let's start with the width. Right-click on the rectangle's width property and open the expression field. The width of the bar should be the width of the screen, which is 1, minus the left and right margins. Those properties can be referenced in expressions using their name. Awesome! This expression field is super small. It's okay with short expressions like the one we just wrote, but it's difficult with longer expressions. Here's a great tip. You can write your expressions in an external text editor and paste them in. On Mac, I like using Sublime. On Windows, try Notepad++. Now let's write an expression for the height. That will be 1 minus the top margin minus the bottom margin. That's the height of the active graph area. But remember, the height of each bar will be affected by the number of rows and padding. I'm going to put that expression in brackets. They help you to control the order in which mathematical operations are carried out. So we will take that number and divide it by the number of rows. And then finally, we need to take account of the padding. It's easier to think about the bit you want to keep rather than the bit you want to get rid of. If the padding is 10%, then we are keeping 90% of the bar. It's easy to convert that padding figure into the bit we want to keep. It's 1 minus the padding. Then we can multiply the height of each bar by that factor. I'm using brackets again to make sure we don't have any issues with the order of operations. I will copy it and paste it into Fusion. That seems to be working well. Finally, the position of this bar should change depending on what the row slider is set to. Let's create an expression for the bar's position. That's defined using the center property. This property contains two values, x and y, so you need to use this point function when writing your expression. The first value is x and the second value is y. In Fusion's coordinate system, the bottom left-hand corner of the screen is 0, 0. Let's copy the existing expression out of Fusion and paste it into our text editor so we have a little more room to work. By the way, something you might see me doing is writing my expressions in chunks across several lines. I find it easier than trying to do it all in one line. The expression I will write eventually will replace that second 0.5. The y position of the bar will be 1 minus the top margin minus the bottom margin. Remember, that gives us the active graph area. Let's pull that all in brackets. Now we need to work out the position within that area. We can get that by dividing by the number of rows and then multiplying by the row number. But there's a small twist here. It's to do with how we are counting row numbers. To make this more intuitive for humans, I'm saying that 1 is the first row because it makes more sense in my head to start counting from 1. Computers like to count from 0. And this expression only works if we count from 0. So I'm going to modify the expression to subtract 1 from the row number before we use it. As always, I'm going to wrap that in brackets to make sure this subtraction calculation happens before any of the surrounding multiplication or division. That expression gets us the position of the bar within the active graph area. If 1 is the top of the screen, we'll subtract the top margin, then the position of the row we just calculated. There's my finished logic. Let's paste it into the point expression and take the whole thing back into Fusion. And voila, check it out. That has worked great. Let's check that all of those controls work. The margin controls allow me to adjust the layout. Changing the number of rows automatically adjusts the height. And changing the position value changes the position of the bar. There's some issues to sort, but I'm happy with the progress thus far. Can I just take a moment to remind everyone, if I was just creating the one animation, I would not go through all the effort of making all these custom controls. But as I'm going to reuse this asset repeatedly, spending time now will save time later. At the moment, the bars run the entire width of the graph. That's no good. We need to be able to change its value. Otherwise, it's not a graph. So it's time to add more controls. It's a little more complex than just one control though. Not all graphs start at 0. That makes it easier to compare large numbers that are very close. And graphs are no good unless all the values are drawn at the same scale. So we'll create controls for minimum value, maximum value, and actual value. That's going to be using the edit controls dialog. But this video will get boring if it's just me making controls, so we'll speed it up. This video is supported by Audiio. If you want to use their amazing library of music and sound effects in your project, you could purchase a yearly license. Or if you never want to have to worry about music licensing costs ever again, you can purchase lifetime access. Normally that would cost $499, but using our discount code Team2Films199, you can get lifetime access for, you guessed it, just $199. That is an amazing deal. As well as the thousands of tracks already in the library, you'll get access to all the new tracks that continue to be added weekly, amazing AI features like Link Match and Hans AI that help you to find tracks by either describing what you're looking for or providing references of similar tracks that you like. And finally, you can download stems for every single track that allows you to more easily remix them. Using our discount code and supporting our sponsors is an excellent way of supporting our channel. Thanks so much for watching. Here's the 3 new controls I made. I need to modify the expression for the width of the rectangle to take account of the value. To help me to see if it's working, I've entered test values into the minimum, maximum, and actual value. This expression that's in the width field essentially returns the maximum possible width that the bar can be. So I'll use that to work back to the actual value. Let's copy the expression into our external text editor just to make this easier. Just delete the previous expression before pasting it in. We'll subtract the minimum from the maximum to get the working range of the bar. I'm encapsulating it in brackets to force the computer to calculate any addition or subtraction before handling the multiplication and dividing we will add later. We're also going to need the actual value of the bar. But because the graph doesn't run from 0, it runs from the minimum we have set, we need to subtract the minimum from the actual value. I should put the first part of the expression in its own set of brackets as well. We can divide the width of the bar by the difference between the maximum and minimum, then multiply it by the value to get the width it should actually be. Those brackets are super important. I've already mentioned the order of operations a few times. When a computer processes math equations like these, it processes the multiplication and division before it processes subtraction and addition. Without the brackets, that would alter the results that this expression returns. This is like 3rd grade math all over again. These brackets force it to process the contents of the brackets first. Let's pop that back into Fusion. That works great. Changing any of those 3 properties changes the size of the bar exactly as I would expect. There's one small problem. The anchor point for the bar is exactly in the center. That's why it expands outwards instead of growing from the left like I would expect a graph to. Annoyingly, the rectangle node does not have an anchor point control. So I've got to do this another way. Keep in mind the anchor point of the rectangle is in the middle. Essentially, what I'm trying to do is left justify the rectangle. I'll modify the x value of the center expression. Left margin plus half the width. There's no need for brackets here. That works well. have a similar issue with the bar's vertical position. That too needs to be offset by half its height because at the moment, its position is defined using its center. So I will subtract half the height from its position as well. Make sure you add the code in the right place because we have several closing brackets here. It's easy to pop it in the wrong position. To show you that's working properly, if I reduce the top margin and bottom margin to 0 and the padding to 0, when the row is set to 1, the bar should touch the top of the screen. And yep, it does. And when I set it to be the last row, which in this instance is row 10, it touches the bottom of the screen. Perfect. Everything is working. I know there was a bunch of work involved in setting that up, but can you imagine how time-consuming it would be to build each of these bars manually? Let's take a break from the expressions to make some aesthetic changes. I'm going to add curved corners to the bar using this control on the rectangle node. 0.2 looks great in my opinion. And I'm going to change the color of the bar, something more colorful. I like this blue for now. And I love a drop shadow. There's a tool for that. I'll add it to the composition. Let's tighten it up slightly. And nice, that works great. With any job, there's that tough bit at the beginning where you are putting all that hard work into getting everything set up, but you don't see an awful lot of progress. When a house is constructed, builders will spend weeks and weeks preparing the foundations, right? And from a distance, it might not look like anything is happening, but it's incredibly important work. And then comes the fun bit when you see the house start to rise. We're at that stage now. Let's add text to display the value of the bar. We'll use the text plus node and merge it onto the bar. I can have this display the value of the bar using a simple expression. Right-click on the text source, enable that expression editor. When you reference a control in the same node, you can just type the control's name. If you're referencing a control in a different node, you need to type the node's name first. Type rectangle 1, value, hit enter, and instantly it's displaying the bar's value. That will update anytime that property changes. There's 3 problems. First, value is a non-integer control. It can have decimal places like this. They don't look great when displayed. Second problem, position. And third, size. It's easy to neaten up the number using the math floor function. This will floor the decimal value to the nearest integer, so that means it always goes down. Essentially, we are just stripping off the decimal places. Remember, you need to put value inside of the brackets for the floor function to work. Now let's deal with the other problems. I want this value to sit on the right-hand side of the bar, and the Layout tab of the text node, that's where you will find the position controls. Turn on the expression editor. It's another one of those point expressions where I can deliver separate values for x and y. We'll start with y because I think it's easier. I can reference the position of the bar from the rectangle node with the following expression. Looks great. Before we deal with the x position, is it okay if we deal with its size first? In the text plus node, a text size of 1 means that the text will be the height of the frame. That's the exact same way the rectangle tool works. That's cool. That means I can use the bar's height as the text size. All I need to do is type rectangle1.height. That's a really cool start, but I don't want the text to be so close to the edge of the bar. I think it should have some padding, right? Instead of hard coding a specific padding value into the expression, let's make a control that allows me to adjust the amount of padding. But I think to keep things neat, I'm going to keep all my custom controls in the rectangle 1 node. So I'll add a new control called text padding. It's going to be a slider with its allowable range between 0 and 0.2. This is going to be a relative value rather than an absolute value. That's why I've set the allowable range so low. At 0.1, the padding will be 10% of the height of the bar. If I created a control that allowed me to enter an absolute value for the padding, I could get into trouble if I entered a padding value that was larger than the height of the bar. Instead, a relative value will scale with the size of the bar. Let's work that padding value into the text size expression. As the padding gets taken off twice, once from the top and the bottom, I should multiply it by 2, and then I'll subtract it from 1. It's simple enough, I'm going to just type it straight into Fusion. And it works. Marvelous. Finally, let's fix the horizontal positioning of the text. Let's change it to right justification. To find the right-hand edge of the bar, I can use a combination of the left margin and the bar's size. Left margin plus the bar's width will let me find the right-hand side of the bar. You can see the text is now positioned on the right-hand side of the bar, which is awesome, but that leaves the text touching the right-hand side of the bar like exactly. There's no padding, and we want the padding to match the vertical padding. This is getting a little complex, so I'm going to copy it out of my text editor. As I defined my text padding as a percentage of the bar's height, to convert that to something I can use on the x-axis, I'll need to reference the bar's height, the text padding value, but also the aspect ratio of my composition. That's because the height and width coordinates don't use the same scale. One is the height of the frame, and it's also the width of the frame, even though they are different sizes. So, for example, 0.5 goes further width-wise than it does height-wise. Following me? If I multiply the rectangle's height by the text padding, and now I need to multiply all that by the aspect ratio to convert it from a vertical measurement to a horizontal measurement. You can reference the size of the composition using this expression. If I divide the height by the width, it will give me the relationship between the height and width. So if I multiply everything by that figure, it'll convert it so it'll work as a horizontal measurement. Now I can subtract it from the x value we already produced. Reassemble the expression and paste it back into Fusion. That works perfectly. Now the text isn't touching the edge of the bar, it's got the same padding on all three sides. I could have used that vertical padding figure without converting it. It would have been such a slight difference, but I'm happy I was able to show you that slightly more precise way of doing it, just for fun. Let's just take a moment to see how far we've come. I have custom tools that allow me to define the layout of my graph and specify the number of rows. I can decide which row in the chart this bar occupies. I can set its scale using the minimum and highest value sliders. And as I change the bar's value, the text automatically displays the correct value. If Fusion's relative coordinate system is a little different for you, if maybe you're used to After Effects' absolute coordinate system, this might be a learning curve for you. Both systems have distinct advantages. Here's two key advantages of Fusion's coordinate system. It's resolution independent. You can change the resolution of your composition and it will scale accordingly, which is awesome. Second, I find the math easier to do in my head. Imagine trying to work out the coordinate for the center of the screen when working with absolute coordinates. That's going to be something like 960 by 540, whereas the Fusion's relative system, it's 0.5. which is much easier. Now, let's add a title. I don't want the title to be overlaid on the bar, I'd like it to the left. Let's use the left margin tool to push the graph over a little, and a new text node. Merge it with the existing image pipeline. I'll put some placeholder text in here to help us as we work on it. It's going to be to the left of the bar, so let's change its horizontal alignment to right justified. We'll deal with the size first. I can reuse the expression I made for the size of the value text. Just paste that in, super easy. I can also reuse the expression I created for the text vertical position. Writing the expression for the x position is going to be pretty easy as well. It's the position of the left margin. This is coming together nicely, but I don't want the text to touch the bar. I can use that text padding value I created, but I think a larger gap is required. So I'm going to make another custom control. Again, in the rectangle 1 node, so I can keep all those controls in one tidy place. I'll call this text indent. Unlike the padding, I'm going to make this an absolute value. That means it won't change as I adjust other parts of the graph's layout. I'll allow values from 0 to 0.02. I'll set the default to 0.01. Now I can subtract that value from the left margin. The expression to access that will be rectangle1.textIndent. Awesome! Remember, because it's an absolute value, this gap won't change as I resize the graph. This is so cool. I'm going to add 2 more controls to this tool. First, the graph might look kind of overwhelming with the text this big. I'm going to add a control called text size to the rectangle node. It will have a slider that goes from 0 to 1. At 1, the text will be as big as it can be. As you pull the slider down, the size of the text will decrease. All I need to do is multiply the text size by that value. Let's copy it out, just so I can see what I'm doing. Oh yeah, that's a nice simple one. Let's just multiply everything by that text size factor. I'll update the expression on both text nodes. And now check this out. That works really well. Hey, I don't know if I'm going to need that option, but it's better that I code it in now, just in case we do. Finally, let's add a control that allows us to animate the bar's visibility. It's going to be another slider. This one will go from 0 to 1, and its default will be 1. Now, why am I using a slider for the visibility rather than a simple checkbox? Checkboxes are either on or off, whereas a slider, where 0 means it's not visible and 1 means it is visible, has all the values in between 0 and 1, right? That means when I animate the visibility of the bar, I can use the changing value of the slider to animate it on and off. We're going to slip this visibility value into a bunch of the expressions we've already written. We'll start with the width of the bar. It's determined by the value slider, right? Wherever we use the value control, we will multiply it by the visibility value. Check this out. At 0, the visibility slider makes the bar disappear, and at 1, it will be at its full value. There is a problem here where the text comes off the graph. We'll fix that in a bit. Let's add the visibility variable to the text node that displays the value. Now that changes with the visibility slider as well. We just need to find some way of having the visibility slider affect the bar title as well. I could just link it to the opacity of the text. Kind of boring. How about we use it to have the text right on? It's the end value we want to write an expression for, so make sure you right-click on that specifically when enabling the expression. The easiest thing to do would be to have it linked directly to the visibility value, like this. However, I want the text to write on quicker than the bar animates on. If I multiply the visibility value by, say, 2, then it will animate on twice as quick. Nice and easy fix that was. All right, let's address that small problem with the value text running off the bar when there's a low visibility value or the value of the bar itself is low. This is one of my favorite things about node-based compositing. It is super easy to reuse nodes in different parts of your composition. I can use the rectangle shape as a mask for the node that merges the text with the composition. That way, the text will only ever appear inside of the rectangle. So cool. We can do slightly better though, because I still don't like how abruptly the text gets cut off. I'd rather a fade on the left. Here's one way to fix that. I'll create a new rectangle node. Let's equip it in the viewer. So it works no matter the position of the bar. I'll set its height to 2. That means it's as tall as the composition and some more. That's helpful for when we set a feather on the rectangle's edge. As all 4 sides of the rectangle get softened, making it much higher than we need means we essentially won't see the top or bottom feather. Now we can return the viewer to showing us the entire composition. Let's add an expression to the rectangle's position. I only need to control its x value. Simple as that, this little fade is now lined up with the left-hand side of the rectangle. I'm going to combine it with the rectangle shape that's being fed into the mask of the merge node. I've connected it between the 2 nodes. Let's equip it in the viewer again. By default, it adds the 2 masks together. I want it to subtract the feather mask from the rectangle mask. And hey, that's so cool. Back to viewing the entire comp. check that out. All right, we are done. It's time to export this as a macro, and I'll show you how to use it. Macros are collections of nodes that you can reuse on both the Edit and Fusion page. I've tidied up the controls because their values at the time of macro creation will be the default values when this tool is loaded. First, you need to select the nodes that you want to be included in the macro. You don't need to include the media out node. Then go to Macro, Create Macro. This dialog allows you to select which controls are exposed in the macro. Every single node in the macro, can we say macro some more, is shown here. There's a lot of control that we could choose. Because we put all of our custom controls in one node, the rectangle 1 node, it makes them pretty easy to find. I'm going to include all of them in the macro. There's only 2 controls outside of the rectangle 1 node that I want to include. First, the color controls for the background node. So I can change the color of each bar. This one's a little counterintuitive. To have full control over this node's color, it's best to include all 4 of these controls. Second, the text field for the bar's title. You can even change the name it will be given in the inspector. And that's it. Hit close. Resolve will ask us whether we want to save the macro, and yes sir, we do. For Resolve to see the macros we create, they need to be saved in a specific folder. The folder that is open by default in this Save As dialog, it's not my preferred place to save macros. Firstly, because it's within my user folder, so only I will see these macros rather than any user on my computer. Secondly, because it's not as flexible as a different folder called Templates, that allows you to decide what page and what categories your macros can be found. Let me show you. On a Mac, the template folder that all the users can access is found in Library, Application Support, Blackmagic Design, DaVinci Resolve, Fusion, Templates. On Windows, a similar path, but it starts in your program directory. Here's a top tip. Save this templates folder as a favorite to make it easier to access in the future. Your folder might not have these subfolders already. If it doesn't, just create whatever folders you feel you need. I want this tool to be accessible in the Fusion page. If I wanted it to be accessible in the Edit page, guess which folder I'd save it into? That's right, the Edit folder. Please note though that tools saved in the Edit folder must be in one of 4 subfolders: Title, Generator, Effect, or Transitions. That's not the focus of this tutorial, but just wanted to mention it because it's pretty fundamental. So, like I said, I'm saving this macro in the Fusion folder. Give it a name. And hit save. Right, let's go back to the Edit page. Going to make a blank Fusion composition. You can keep this old Fusion composition safely somewhere for when you want to edit and improve your macro. To access the tool, open up Effects, go to the Templates folder, and your new effect is in here. Searching for it is usually easier than scrolling. And look, here it is. When you drag it into the composition, all of those nodes and controls you built are displayed as a single control. How cool is that? Something I'd like to fix before going any further though is the order of these controls. They've been added in the same order they've been created, but that's not the most intuitive really. The easiest way to fix that is with a text editor. Open the folder where you saved your template and open it up in your text editor. Just as a reminder, I've been using Sublime on Mac, and on Windows, try Notepad++. The custom controls are all up the top here. Reorder them as you wish. Just one thing to watch out for, there needs to be a comma between each control. If you mess that up, you'll break the macro. There's one other little bit of housekeeping I'd like to do while I'm here. The controls that I've chosen to expose in my macro have all been given generic names, input 1, input 2, and so forth. I'm going to rename them, give them the same names I've given the underlying controls, and that will help me when I want to reference them later. All right, I've reordered my controls, I've saved the .setting file, and to benefit from those changes, I'll delete the macro tool I already inserted and reinsert it again from the effects menu. And there you go. A graph will likely have several bars. I'm going to use a multi-merge to combine several instances of the bar tool. I'll start with just 2 for now because I want to show you something cool. I'm going to link the common controls together so I only have to change them in one place. This will be my master bar tool, so I'll set up the second bar tool to reference it. My preferred method in this instance for linking those controls together is with expressions. I'll work my way through each of the common control, adding an expression and linking it back to the master tool. As I did all that work earlier, renaming the tools in the macro, I can do this part from memory. I don't even need to use the pick whip. I'm setting this up for the left margin, right margin, top margin, bottom margin, rows, bar padding, minimum, maximum, text padding, text indent, and text size. What's really cool is that if I copy this node, it copies all of the expressions I created. I'm going to have 8 bars on this graph. They are not presently visible. That's because they all have the exact same position property. So I'll work my way through one by one, adjusting each bar's position values 1 through 8. Let's change the number of rows to 8. If I do that on the master bar, look, it automatically adjusts all the other bars. I can change the margins, the padding, the text size, and each bar gets updated in sync. I can also control the scale of the graph using the minimum and maximum controls here as well. And if I want to increase the number of rows in the graph, I can do so and add additional bar tools. We see all our hard work coming together. Let's add some pretend data to this graph by adjusting the text and values for each bar node. Next, let's animate the visibility properties of each bar tool to reveal the graph, 1 bar at a time. At frame 0, I want visibility set to 0, and then it will increase all the way to 1 over the course of 24 frames. I'm going to work my way through the rest of the bars, adding the same animation, but offsetting it so that each bar starts 4 frames after the previous one. You might have an animation where you want the bars to animate on in sync with the script, so you don't have to animate them the way I'm doing so. You can do it however you want. Now that my animations are set up on each bar, I'll open up the spline editor to ease that animation. They will look more organic if these animations are eased, which is easy to do. No pun intended. So let's just select the keyframes and hit F for flat. It adds a flat Bezier handle to each keyframe. Oh, and let's give this chart a black background while we are here. Let's see what that looks like. Pretty cool. There's one last animation I want to add to make the values of the graph change partway through. Let's just pop to the edit page to make the composition a little longer. Right, done. Red has a top score. I'm going to give it an even higher score, so I'll set a keyframe at the 100th frame. And then another keyframe at frame 150, where its score is 500. That's a problem, right? Look, the bar has gone off the edge of the screen. That's no good. I should adjust the maximum score to change the scale of the graph. Let's add a keyframe for it at frame 90. Add another keyframe at frame 140, where it has increased. I'm having the maximum change slightly before the value increases change. And lastly, let's just ease those new keyframes. Here's the awesome thing. Even at this developed stage of the animation, because we took the time to create sliders for each of these settings, it's super easy then to tweak the look of the graph. For example, these bars look too big, so let's play with the padding and maybe the text size. Let's fix that yellow bar that's too light, making it difficult to read the text. Let's change the backdrop color to gray too, so we can see those drop shadows again. Much better. All right, what did you think of that? Yes, that involves some effort, but imagine if you're regularly creating graphs in your content. Spending time to create a tool like this not only saves time in the long run, but increases the quality of your graphs. And the reality is that a well-structured, considered approach to solving a problem, like the one we've just created, often ends up saving time over more direct ad hoc approach, even on small jobs. It's possible to add even more complex features to your bar tool. In our M4 video, our graph featured the ability to switch between showing absolute and relative scores. It's also possible to take the bar tool that we've created and then build that into a single graph tool with simplified controls, and for that tool to be accessible on the edit page. You can turn all of these nodes into an even bigger macro. Imagine how quick that will make you being able to build dynamic graphs in the edit page inspector. Or a slightly simpler option would be to save this Fusion composition as a template. In the edit page, if you drag it from the timeline into a bin, you can now reuse this wherever you want by dragging it into the timeline. Don't worry, changes made in the timeline won't affect the template. It's not a two-way link. For extra points, you could enable power bins, store your awesome Fusion graph template there, so you can access it across multiple projects. If you want to learn how to better use DaVinci Resolve, we think you will love our course, DaVinci Resolve for Editors. There's over 9 hours of training. It comes with practice media, and it covers media, edit, color, and fairlight, and deliver pages. They say necessity is the mother of invention. When you have a job to do, you figure out how to get things done. But when you're self-taught, or you've pieced your education together one video at a time on YouTube, you don't know what you don't know. Whether you're starting out on your journey, or you've been using Resolve for some time, we've designed our course to be a rewarding experience. If you'd like to see it, if it can help you or not, please check out the free sample lesson in Module 4. If you enjoyed this video, give it a like so we know you enjoyed it, and consider sharing it with a friend. Videos like this take a long time to plan, shoot, and edit, so we really appreciate your support. And if you've enjoyed the video, but know you do not have the time to put this tool together yourself, I've got some good news for you. There's a link in the description below where you can download the tool ready-made. And finally, but definitely not least, a big thank you to Audiio. Supporting our sponsors is an awesome way of supporting our channel. Make sure you're subscribed so you don't miss out on our future videos. Thanks so much for watching, and we'll see you next time.